This is the video for algebraic representations of transformations for Math 8. And just remember, a transformation is a change in side or position of a figure, but the transformations that we're going to be working with only are going to be changing the position of the figure, not the size. We'll be getting that soon. But right now, the three that we're going to talk about and just review are changing just the position. So when you're back in first, second, third grade, when you were working with coordinate geometry and the geometric shapes, you guys use different words as in slide, flip, and turn. Well, we're going to make sure that you use the appropriate language for this age group, for 8th grade and beyond, is that when you have a slide, that's a translation. So a translation will slide the figure either horizontally or vertically. So you're either going to go left or right or up or down. So if you want to put that into, that's fine. So left or right, up or down. Now, when you flip a figure, that is called your reflection. A reflection will flip the figure across a given line. Okay? And then, see, a lot of times it's your X or Y axis. Or it could be like a line equals Y equals 2 or X equals -2. So it could tell you about a certain line. So the third one that you know about turn is your rotation. So a rotation will turn the figure around a given point. Most of the time now, when we talk about our rules down here, these rules apply to the origin when you rotate around the origin, not necessarily keeping one point still. So here we're going to go ahead and use our coordinate mapping. All of these you have in your other packet, but we wanted to keep it concise and very easy for you to find. So you can use this, you can keep referring back to this, just so you can have a guideline for you. So on transformations, our coordinate mapping, when we translated your shape, when we used before, to the right, notice your X value is going to change. And when we go to the right, you're going to add. Now we're going to use the letter A here because that can be any number. So we can go to the right 5, right 10, right 1, right, just 2.5. So you're going to have your X plus A, whatever your units are, and then your Y value is going to stay the same. Left, again, you're only shifting left to right. So the left is going to be X minus A, but the Y value is going to be the same. So in your notes, you had numbers here. But when you have this, you're just going to replace that A for whatever the number is that they give you. Now, translating up or down, when you move that shape up or you move that shape down, that is going to not affect the X axis or the X value at all, but the Y. So the Y, that would be Y plus B. So whatever your Y coordinate is in your pre-image, when you shift it up, when you translate up, then you're going to be adding to that Y value, keeping X the same. When you shift down or you translate down, you're going to have Y minus B. Again, the A and B are going to represent whatever numbers, however many units they tell us to translate that object. Okay, now reflection. When you reflect across the x-axis, when you did this before, remember your x-axis is horizontal. When you reflected across the x-axis, the x value stayed the same, but then the y's became opposite of what they were before. So this is how you symbolize it. You want to do the opposite of. So this means, if you want to put opposite of, so it means the opposite of. It does not mean that your y value is always negative. It's just the opposite. So if your y value started at -2, the opposite of that is going to be 2. So this means the opposite of. Now the y-axis, if you're going across the y-axis like this, then your x value is going to be the opposite of x, but your y is going to stay the same. Okay, so again, this means the opposite of that negative sign here. So the opposite of that. Okay, now rotation. Rotation is where you turn it. And so usually when you have a rotation, they'll be in degrees such as 90 degrees, 180 degrees. You might see 270. If someone tells you to do a 360, you're flipping all the way around. So the rotating, when you rotate 90 degrees, now the direction matters on the 90 degrees because you need to know if you're going clockwise to the right or if you're going counterclockwise to the left. So now if you go clockwise, 90 degrees clockwise about the origin, sometimes you hear this around the origin, but about the origin is what you're going to hear in high school. And so what happens is your X and Y, if you recall from your packet that you were working on the other day, then you recalled that the Y value, instead of being at the end, whatever that number is, became the front. That's going to be your first point, or your first ordered pair, part of your ordered pair, and then your X is going to be the opposite of the X. Okay, so look back at your rotation to help you understand what just happened here. 90 degrees counterclockwise about the origin is that the Y value, they do flip, so both of them do change positions, but the Y value, whatever it is, it's going to be the opposite of what it was, and then the X value stays the same. But they do change position. Now 180 around the origin, or about the origin, 180 means it's going halfway through, so it's really ending up in the diagonal coordinate grid. So, I don't have a coordinate grid here for me. But what it's going to be doing, it's going to change it to the opposite of whatever X was and the opposite of whatever Y. So if these were both negative, your new ordered pair would both be positive. If they were both a positive, they would both be negative. So it's just doing the opposite of whatever the original ordered pair was. Okay, so let's do a quick practice. Identify the transformation from the pre-image figure to the image. So here's our pre-image. A triangle with coordinates of A, 0, 0, 1, 4, 3, negative 2 is transformed so the coordinates A prime, so that tells us this is our new shape here, 0, 0, negative 4, 1, 2, 3. What's the transformation that could be performed? So, and note, when making a new image, the A prime is read as A prime. So that it's prime notation. So what I'm going to do to make this a little easier so I can see it, I'm going to go ahead and list them again right here. And then I'm going to list the image, that's the pre-image, the image right underneath it. For me, I think it's easier to see the relationship. Okay, so what we're doing here is we're analyzing how this can change. Okay, with this first one, well, it's the exact same point. So this really could be, since it's the same point, okay, that could be a rotation or a reflection. Since 0 could equal a negative 0, so the reflections are going to be the opposite, but since there's no such thing as a negative 0, that could be the same. So I can't tell enough of just by that first point. So don't think you can just tell it by the first point. So I'm going to look at the second point here. All right, so we have 1, 4 and negative 4, 1. All right, so notice what they are. They're the same numbers pretty much, but they change and like they changed positions. So again, looking up here, which one changed position? Well, okay, so it's a rotation. So I know it's a rotation because they changed positions, but now I'm going to look at what stays the same. So this X value here at 1, when it moved to the Y, it stayed the same. So which one? Okay, so the X here, it moved to the Y position and the X stayed the same. The Y came up to the X position, but it became opposite. So this one is the opposite. So this is going to be, so we know it's going to be a 90 degrees because they changed location. So we know it's going to be a 90 degrees. So, and since it changed positions and the Y became opposite and the X stayed the same, it's 90 degrees counterclockwise. So this answer up here is 90 degrees counterclockwise. And you must tell us counterclockwise, otherwise we don't know which direction to turn it. 180, now that won't matter which direction because it's going to be the same either way. But hopefully that will help you determine your answers on the back of the packet that we've been doing. That last page in the back packet, use this to help answer those questions. Okay, thank you.